Yeah, at least. So if I say I have at least 5, because I think what mixed me up was I said at most at first, and then I'm putting it under at least, and so I'm getting those words that I'm thinking about mixed up. So let's just talk about at least for right now. If I have at least 5 pennies, then I have how many in my hand? 5 or more. Okay? So at least means this inequality, greater than or equal to. That's what at least means. Because that means 5 or more, right? Okay. If I say I have at most 5 pennies, then I have 5 or less. So that means less than equal to. So when we do those inequality word problems, you're going to see the words at least. What inequality symbol are you going to use if you see that word? Those words at least? Greater than equal to. If you see the phrase at most, then you can use what? Less than equal to. All right. Let's look at 59. So 59 says this: 6 more than twice a number. You got to look at. You can't see it up here. You have to use your own paper. 6 more than twice a number is greater than negative 14. And you want to find all the numbers that make this statement true. All right. So we're going to find those numbers, right? So you're going to let x equal the numbers, the possible numbers. All right, so using that first statement, 6 more than twice a number, how does that expression look? 2x plus 6, okay, or 6 plus 2x, right? So 2x plus 6 is greater than, what is that? The inequality symbol greater than negative 14. And there's your inequality statement. And all you got to do now is just solve for x. So what's the next step? And so 2x is greater than negative 20, and so x is greater than what? Negative 10. All right, so the question is, find all numbers that make this statement true. So what numbers make this statement true? Make this statement true. Any number greater than negative 10. Okay? So any number greater than negative 10. So any number greater than negative 10 makes this statement true. Okay, so what you just found. Okay, 61. 61. So when you do Mymathlab, just use those examples as a guide. All right, so the perimeter of a rectangle is to be no greater. The perimeter of a rectangle is to be no greater than 100 centimeters. And the width must be 15 centimeters. And you will find the maximum length of the rectangle. All right, so if you look at this rectangle, you are told in this problem that the width must be how many centimeters? 15. No. You got to read the problem. The width must be what? 15. That's what you're told.
Oh, yeah.
And first of all, what do we mean by perimeter? No, that's area. What do you know about perimeter? Perimeter is the distance around the figure, guys. Perimeter is the distance around the figure. If you go around, that's the perimeter. So if this is 15, that means this right here is what? 15. Okay, then it asks this. It says, find the maximum length of the rectangle. Now remember, you want the perimeter to be no bigger than what? 100. So you'll find the maximum length of the rectangle. So you're going to let x equal the length of the rectangle. So that means this right here is what? X. And this right here has to be what? X. All right, now let's set up the inequality. This is not an equation, it's an inequality because it uses the words no greater. It doesn't say is the same as, it says what? No greater than. So if I were to look at this perimeter right here, what would I do to determine what this perimeter is? Add them up. So x plus x is 2x. 15 plus 15 is 30. So that's this perimeter. So this perimeter right now is 2x plus 30. That's the expression. But you're told that you want this perimeter to be no bigger than 100 centimeters. So what inequality symbol is that? Less than. So no bigger means that my numbers have to be what? Less than or equal to. Okay, so you say less than or equal to 100. Because it says it can be no bigger than what? 100. So that means it has to be less than or equal to 100. All right, not less than 100, less than or equal to 100. That's what no bigger than 100 means. Okay? So it has to be less than or equal to 100. So there's your inequality. You just solve for x. So what's the next step?
Subtract 30.
Subtract 30. So I get 2x is less than or equal to 70. So x is less than or equal to what? 35. All right, now you got to answer the question. You got to divide by 2. 7 divided by 2 is 35. You got to answer the question, though. It says find the maximum length. The maximum length. What do you think the maximum length is?
35.
35. See how this answer is different than this one? So here, you're going to say the maximum length has to be what? 35. So the maximum length is 35 centimeters. Okay. So notice how the answer looks compared to what the question was in each problem. Okay, 63. All right, 63. Okay, so in 63 it says, Ben bowled 146 and 201 in his first 2 games. What must he bowl in his 3rd game to have an average of at least 180? All right, so he's bowling 3 games. The first game is he bowled 146. The second game he bowled 131. He's going to do a 3rd game, but he wants the average to be at least what? He didn't say he wants the average to be 180. He wants the average to be what? At least 180. What symbol represents at least? Greater than or equal to. All right, now how do you find the average of something if they all represent the same amount? Add them up and divide by the however many you have, right? Okay. So you would let x equal the 3rd game score, I guess, in bowling. Score of the 3rd game. All right. So how do you find the average, given those numbers that are in the problem? But tell me what to write, though. Come on, guys. The numbers are there. Tell me what to write.
146.
Good. 146 plus 201 plus x, all divided by 3. And it says it must be at least, so what's the inequality symbol? Greater than equal or equal to 180. So there's your inequality symbol. And then you just solve for x. Now what I would do first is combine like terms of that numerator. Using your calculator. Actually, you don't need a calculator for that one. 146 plus 201 is 347, right? Plus x divided by 3 is greater than or equal to 180. All right, thinking about test 2, what would be your next step? Thinking about what you did with test 2. Okay, so you find the LCD. What's the LCD? So you multiply both sides by 3. All right, so times 3 times 3. Now remember, the whole purpose of multiplying by 3 is to get 1 in the denominator. So 3 into 3 is 1, 3 into 3 is 1. So what's left on the left side?
347.
Okay. And 180 times 3?
540.
540? Okay, what's the next step? Subtract 347. And combine terms, I get x is greater than or equal to 540 minus 347.
193.
Say it again?
193.
193? All right.
Is there a way to darken the projector a little?
No. Well, I could possibly turn. That's about
That's a little better.
all I can do.
Yeah, that's a little
Okay.
better.
All right. Now you got to answer the question. What does this mean right here?
What is the average?
No.
You have 193. Well,
190. You have to score at least 193 on that third game to get an average of at least what?
180.
180. All right. So he must score or bowl at least 193. So 193 or more, right, on that third game?
Mm-hmm.
To have an average of at least what? 180. All right, so that's what this means. So he must bowl at least 193 in the third game so that his average is at least 180. So if he scores less than 193, his average is not going to be at least 180. It will be less than 180. Okay. That's 63. All right, 65. All right, 65. Okay, it says Dennis and Nancy are celebrating their 30th wedding anniversary by having a reception at Tiffany's Oaks Reception Hall. They have budgeted $3,000 for their reception. If the reception hall charges $50 cleanup fee plus $34 per person, find the greatest number of people that they may invite and still stay within their budget. All right, so they want to spend at most how much money? $3,000. Okay? They don't want to spend more than $3,000. So $3,001 or $3,002? No, it has to be 3,000 or what? Less. Okay. Now, part of this is very similar to that equation word problem sheet you did before. See, it says charges $50 cleanup fee plus $34 per person. So if you want to find out how many people, what's the greatest number of people they can invite, you would let x equal the number of people. Let x equal the number of people. All right, now let's talk about the inequality you're going to write. Okay, so the part that says this, they have the reception hall charges $50 cleanup fee plus $34 per person. How would you use that to determine how much they would have to pay for X number of people? 34x plus 50. Good. 34x plus 50. It's very similar to the word problem that looked like this in a previous section. I think it was section 9.4. All right. So that's going to be the cost. This is a cost for X people. But you know something about the cost. What do you know about the cost? It has to be less than or equal to 3,000. All right, so there's your inequality. All right, what's the next step? Subtract 50. And so I get 34x is less than or equal to 2,950. All right, use your calculator. When you use your calculator, and you divide both sides by 34, look at what you get in your calculator. All right, so 2,950 divided by 34, I get this. Okay, so this says this. This says x is less than or equal to 86.7647 and so on, right? That's what this calculator tells me. Remember, what did x represent though? Number of people. But I really want to find what's the maximum number of people I can invite and still stay within the budget. 86. Would someone say 87 because you rounded off? Exactly. Very good. Now remember, if you round off to the nearest whole number, since that's 5 or bigger, you would add the 87, right? But you got to remember the context of the problem. To stay within the budget, it has to be that amount or less. And of course, you can't have part of a person. So either you have to use 86 or you have to use 87. One of them is correct. 87 is not. And here's why 87 is not. If you plug in 87 back in here, you say 34 times 87 plus 50 equal, what do you get? More than 3,000. You may say, well, my friend can give me the $8. Yeah, but that's not what we want here. We want to know, suppose it's strictly 3,000. I don't care what your friend gives you. If it's strictly 3,000, that's all you can spend, no more. Then you cannot invite 87 people. You can only invite how many people? 86. So the maximum number of people they can invite is 86. 86. And you can check 86. If you check 86, let's see what the cost would be. 34 times 86 plus 50. You get 2,974. Is that within the budget? Yep. So the maximum number of people they can invite is 86. So they can invite 86 or less. But the maximum number is 86. 67. Okay, so in 67, you have that so anyone weighing 150 pounds uses 5.8 calories per minute when walking at a speed of 4 miles per hour. So if you weigh 150 pounds and you walk 4 miles per hour, how many calories are you burning off per minute? 5.8. Okay? And it says this: how long must a person walk at this speed to use at least 200 calories? And then you round up to the nearest minute. Okay, round up to the nearest minute. That's what it said. All right, so how long must a person walk at this speed to use at least 200 minutes? So you want to find out how long, right? So you would let x equal the number of minutes. Since this says 5.8 calories per minute, let x equal the number of minutes. All right, now, what do you think is going to be the inequality? Say it again? Okay, at least it's going to be greater than or equal to, but what's going to be the statement, though? 5.8 calories per what? Minute. So if I walk 1 minute, how many calories did I use? 5.8. If I walk 2 minutes, how many calories did I use? Whatever 5.8 times 2 is, right? So what's going to be that expression? 5.8x. So 5.8x. And so that's going to be the number of calories I use. That must be at least what? 200? Okay. And so there you go. That's it. So sometimes, though, when people see all numbers in a problem, they think they have to use all of them. But remember what I said. I said if you weigh 150 and you walk 4 miles per hour, then how many calories do you use a minute? 5.8. If you weigh 200, then that number is going to be different, right? It won't be 5.8 anymore. If you weigh 300 pounds, it won't be 5.8. That 5.8 is only for what? A person weighing 150. Okay? All right. Now how do you get x by itself? Divide by 5.8. And so x is greater than or equal to, okay, if you put this in your calculator, 200 divided by 5.8. And so you get x is greater than or equal to 34.4827 and so on, right? Now the problem said round up. Round up. Now if it said round off, then 34.4827 becomes what whole number? No, if it said round off. 34. So remember rounding off to the nearest whole number. If this is 5 or bigger, this 4 becomes a 5, but it's not 5 or bigger, right? But the problem said this, round up. So no matter what this decimal part is, you have to make 34 become a what? 35. So remember the difference between round off and round up. Those are different. So the way you're going to answer this, it said, how long must a person walk in the speed to use at least? Okay, so a person must walk. Yeah, person must walk at least 35 minutes to use or burn off. To use what? 200. To use at least 200 minutes. 200 calories. Okay. So round off versus round up.
Can you explain that? Last semester they didn't say anything about the difference between round off or round up. It was like round
Okay, so if I say, usually when you talk about round up, you're dealing with a whole number. So we're going to talk about rounding up, rounding off in terms of a whole number. So if I say round to the nearest whole number, round off to the nearest whole number. So I want these to become whole numbers. You got to look at the tens place. This tens place is less than 5. If it's 5 or more, this 80 becomes an 81.
Right.
Okay? So if I say round off to the nearest whole number, that's what this says, round off the nearest whole number. You gotta look at the tens place. Since that's less than 5, 80 stays 80. Since that's less than 5, this stays 80. Since that's 5 or more, this becomes 81. If it says round up, it has nothing to do with place value. This becomes 81. Okay? This becomes 81. This becomes 81.
So rounding up only pertains to the whole number.
Yeah.
Not the decimal.
No.
Rounding off is decimal.
It's based on the decimal. So I could round off the nearest 10th. I could round off the nearest 100th. I could round off the nearest 1,000. Remember all that? Mm-hmm. But you wanted me to compare that with rounding up. So since rounding up is always referring to a whole number, then I said, well, let's just round off to the nearest whole number then.
Did you make that up?
What now?
I've only heard round up. I've never heard round off before.
Oh, no. You can, round off has to do with whether that place value is 5 or more.
Okay.
Round up has nothing to do with the place value.
It's just the next, if you're rounding up, it's the next whole number.
The next whole number.
Down, and it would be 79, right?
No, if you're rounding down to, see right now, look, if you look at this in terms of a number line, this is 80, and this is 81, and this is 79, right? This number right here is more than 80, so let's say it's about here. You agree? All right, so if I say round, so this is my number right here. If I say round down, then what's the next whole number below it? 80. So sometimes it helps if you look at the number line. So if I say round up, what's the next whole number after it? 81. So all of these right here is somewhere around this little area. Okay? All right. Now, if this was 79 point something right here instead, and I say round down, then it's 79. If I say round up, then it'll be 80. Okay. All right. All right, and then that example you see at the bottom, that is where it says example 1. Okay, so it says, and I guess it's very similar to the bowling, because in that problem where we dealt with the bowling, you looked at the average, right? Okay, so let's look at this example. So Susan has scores of 72, 84, and 83 on her English test. Now use an inequality to find the scores she can make on her final exam to receive a B in the course. And the final exam counts as 3 tests. The final exam counts as 3 tests.
83, 84, and 85.
Huh?
What did you say the grades were? 83, 84, and 85?
72, 84, and 83. You have it in front of you, Angela. You have that paper?
No.
Look, it's up here. If you walked in after class began, you'd get those word problems that are up there. And make sure you get the notes. Okay. Now a B is greater than or equal to what? 80. Now your average here is not this, you don't do it the same way, because your average is a weighted score based on tests, worksheets, Mymathlab, final, and all that. Here, for this particular course, they're referring to all the weights are the same, and all they have are tests, nothing else. All right, but it's very similar to the bowling problem. All right, so I want my average to be a B, at least a B, right?
Yes.
So in order for it to be at least a B, my average has to be bigger than or equal to a what? 80. Okay, so when we do that example, my average, A-V-E-R-A-G-E, must be greater than or equal to 80. Y'all agree? Mm-hmm. Okay, so let's talk about the average. My course grade is made up of 3 tests and a what? And a final. Okay? Don't make the mistake of saying 72 plus 84 plus 83 plus X. That's wrong. Divided by 4. That's incorrect. Because what do you know about the final? Yes, you do. Who said nothing?
3. Oh, look, like ask, like we knew the score.
What do you know about the final, guys? It counts as 3 tests. That's what you're told about the final. It counts as 3 tests. So if I want to find the average, my average would consist of 72 plus 84 plus 83 plus what? 3x plus x plus x plus x, right? And x plus x plus x, I'll go ahead and write it like that, is 3x. All divided by 6. Very good, because there are 6 scores there, right? And that must be bigger than or equal to what? 80. So the test counts as, so the final counts as 3 tests. So that's why you see x plus x plus x. All right, so let's combine like terms in the numerator. Using your calculator, what's 72 plus 84 plus 83? 239. Plus what? 3x divided by 6 must be greater than or equal to 80. All right, and then What's the next step? Okay, multiply by the LCD, so you multiply both sides by 6. 66 is 1, 66 is 1. So on the left, I have 239 plus 3x is greater than or equal to 480. What's the next step? 39. And so I get 3x is greater than or equal to, what's that on your calculator? Say it again? 241. I'm just writing what you're telling me. All right. Then divide both sides by 3. And so x must be greater than or equal to 80. Well, what's that? 2. Let's just go ahead and write that as a, what now?
I said it was 80.3333, but then she said something else.
Okay. Yeah, it's not going to be a whole number because 241 is not divisible by 3. Okay. So 241 divided by 3. So it's 80 and 1/3. Right? 0.3333 repeating is 1/3. So 80 and 1/3.
Does it say round?
No, it doesn't say anything like that.
So you just put 80.
Oh, it does say, I'm sorry. I'm sorry, it does. It does. I'm sorry. It says round to nearest 10th. Okay, now, it says round off to nearest 10th. So let me go ahead and write that decimal again.
So the 80.3.
Yep. All right, so if it says round to nearest 10th, look, this is why I'm circling where you want to round off. I want to round off the nearest 10th. In order to round nearest 10th, you got to look at the next place value, which is the nearest 100th. Well, since that's less than 5, then this 3 stays 3. So you can say x must be bigger than or equal to what? 80.3. Right, so you must score on the final. You got to score at least what? 80.3 to get at least a B in the course. All right, so you must score at least 80.3 on the final to get a B. Okay. All right. So that should help you with the work problems on Mymathlab. Now, there's some of you still have not even started on any of the Mymathlab assignments that are open, and they've been open for a while. All right, so you may want to go on Mymathlab because I think one of them was actually due tonight, and or no, last night, I think.
They're both due tonight.
They're both due tonight? All right, I'll extend it until tomorrow night for those two, but some of you need to keep looking at Mymathlab. Huh?
There's another one due in a couple days, right? The 6th.
Yeah, I'm not going to keep that one alone for right now. You need to focus on the ones that are due tonight. So I'll give you until tomorrow night to do it. Okay. All right, so that's going to help you with 9.7. So I'm going to open 9.7 tomorrow. But the only thing with 9.7 that's on your test 3 are the inequalities. The word problems are not on it. But you may want to wait until after Tuesday to start working on 9.7. So I am going to open it, but I'll give you about a week and a half to do it. So just wait until after Tuesday to work on it. 9.7, Mymathlab. Okay, so this came from 9.7. Okay.